Alright, we are back for another Algebra 1 state test prep video. Today is standard S.ID.8, and spoiler will also be standard S.ID.9 because there is only one question. So, if you've been watching these videos chronologically, this is it. This is the last video of the state test review, with the exception of two videos that I have to re-record for various reasons, which I'll re-record those on Monday and spend the class time going over it. So let's get this last video out of the way. Here we go. Question 1. Bryson collects data on the depth of a river at various points and the velocity of the river at those points. His data have a correlation coefficient of negative 0.9382, which scatter plot could best represent his data. Let's talk about what a correlation coefficient is. Correlation coefficient goes from either negative 1 to 0 or 0 to 1. This all depends on whether or not your scatter plot is a positive correlation or a negative correlation. Okay, and positive and negative works the same as you would think it does because it's the same way as slope. If it goes down, it is negative. If it goes up, it is positive. Negative uses the negative 1 to 0. Positive uses the 0 to 1. The key to how strong a coefficient is how close it is to 1. The closer a correlation coefficient is, or we'll refer to it from now on as R, because that's how it's referred to, is to 0, the weaker it is. The closer R is to 1 or negative 1, the stronger it is. So now we have to talk about what does it mean for something to be weak or strong. For something to be a strong coefficient, that represents a line of best fit where the line is through or very close to most of the points. Here's something we used in a previous video. You'll see that this line is very, very close to most of these points. That's why it has a correlation of coefficient of 0.95, very close to 1, because the line is very close to all those points. If I were to change a couple of these and make this into, like, I don't know, 2, and then make that like 26, and then make that like, I don't know, 14, make this like 7, make this like, I don't know, -6, -3, you'll see that the correlation is getting worse and worse and worse. And now our correlation is actually negative because the line started tilting negative. Okay? So this line is nowhere close to most of our points, so it has a bad correlation. It is a weak correlation. So that brings us back to our question. This has a correlation coefficient of negative 9382. If I can get this to focus a little bit better, that would be great. So that means it is a negative graph, which means it's trending downward. And 0.9382 means that it is a strong correlation. So our lines will be close to the point. If I were to draw a line of best fit through point A, it would probably look something like, and this isn't perfect, but it would probably look something like this. You'll notice that this line is trending down. It has a negative slope. And actually, all of these points are really close to the line. Okay? C would have a line that's going up. That would make it positive. So that's out. B, it looks like it's going down. But if you try to draw a line through all this, good heavens, it's not going to be anywhere close. And D has a line that is going up. Therefore, it's positive. So it's out. A is easily the best choice here. Easily the best choice. Question 2. Select all the correlation coefficients that represent a linear model with a weak correlation. So this is anything close to 0. Select all, and I said I'll say it every time, and I still will. More than one correct answer. So, which of these is close to 0? This one? This one. That's it. 0.618 is closer to 1 than it is to 0, so I wouldn't say it's a weak correlation. These two are definitely close to 0, so I would say they're both weak correlations. Question 3. The average price each year for an airline ticket from 2010 to 2018 is shown on the table. The linear correlation coefficient for the data is negative 0.713. Which statement best interprets the linear coefficient R? So, A, airline tickets are likely to decrease as time goes on. You can see that that's not really true, especially considering they increased for the first few years and then only now started to decrease. But then again, we'll table that. The average airline ticket price decreases by 71.3% each year. This is absolutely ludicrous. Think about what a decrease of 71.3% would be. Okay, if you take, even let's look at this way. If you take 387 and you have a 50% off coupon, okay, that's going to give you a ticket price of $193.5. So a decrease of 71.3% would be even more. We have nothing close to this. The average ticket price decreases by $71.30 every year. Again, we don't have anything that's even close to that. The closest is this one, and that was only a drop of $36. So, I'm sorry, $34. It's late. So yeah, not helpful. Airline ticket prices are guaranteed to decrease. Again, up, 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 up. So A, even though we were unsure about A at the beginning, this is why they use the term best, because it's not always correct. It's which one is closest. Airline ticket prices are likely to decrease as time goes on because the recent trend is showing that it will decrease. The fact that this R is negative means that it is trending downward. Question 4. The equation for the line of best fit and the correlation coefficient for a data set are given. Which statement describes the scatter plot for the data? The data points form a nearly straight line. The data points are scattered and do not form a trend. The data points are scattered in a linear trend, increasing from left to right, or the data points are scattered in a linear trend, decreasing from left to right. So we see here our slope is positive, our R is positive, so there's nothing negative about this happening. The data points form a nearly straight line would be a situation where R is close to 1, which it's not. It's kind of right in the middle, right? Well, not right in the middle, but it's not close to 1. The data points are scattered and do not form a trend. This is R is close to 0. It is very far from 0. And finally, the data points are scattered in a linear trend, increasing from left to right. This is saying that the points are somewhat close, enough to tell that it's definitely increasing, but they're not incredible. And that's what this is. This has a correlation coefficient of 0.69. Okay? That means that, it's good, not great, but it's good. Let's see if we can quickly get a sample point with 0.69. Let's do 134, 236, 44, 52, 59, 64, and 72. Ooh, that's really good. 81, 80, I'm going to play around with this. I'm going to see if we can get one that's close, but I don't think I'm going to be able to. Yikes. Oh, well, you know what? That's not bad. So this has a situation where the line is close for a lot of things. Let's get this actually more corralled in. Ugh, it's actually awful. This has a situation where the line is close, but there's just a couple points that are off the line. That's what a like middle of the road R tells you, that there's definitely a trend, but it's just not a super reliable trend. All that to say. All right, here it is. The last question chronologically of the state test review. And oh my God, it's impossible to read. A store manager records the total visitors and sales in dollars for 10 days. The data is shown in the scatter plot. Which conclusion can the store manager draw based on the data? Let's see if we can get like good heavens. I'm trying to get that to be clearer, but okay. Which condition can they draw? An increase in sales causes a decrease in visitors. An increase in visitors causes an increase in sales. An increase in sales is correlated with a decrease in visitors. An increase in visitors is correlated with an increase in sales. This is more logic than anything else. Your sales don't really determine how many visitors you have. This is what we call correlation does not equal causation. An increase in visitors causes an increase in sales. An increase in visitors is correlated with an increase in sales. Let me tell you why it's not causes and it is correlated. And it's specifically because of this point right here. You'll note that you went from 100 visitors where you were making 225 to 125 visitors. You had more visitors but made less sales. That means that while there is a definite trend, you could draw a line of best fit with a very good correlation. However, it's not a guarantee. If it was a guarantee, then it would be causes. But because it's not a guarantee, and you have points that are below and don't make sense, even like this point right here, where you had like 25 more visitors, but the same amount of sales, or this point right here, where you had 25 more visitors and your sales dropped by 100, those mean that you cannot guarantee cause. It correlates. It makes sense, right? But causation or correlation is not causation. Causation implies that it is guaranteed. This is not guaranteed. This is reasonably predictable, but not guaranteed. All right. So with that, that's it. Those are all the questions we have as every release state test question from Ohio State for the Algebra 1 state test. I hope that these videos have helped you. If you have any questions, please let me know. I'm always willing to help. I'll see you in class, and good luck on your state test.